Hello and welcome back to another episode of Math with Stone. Today we're going to be figuring out how many possible outcomes are for a given situation, which will help you with probability because the possible outcomes, are typically the total that would be on the bottom of the probability. So, if you were ever at a restaurant and you're like, I wonder how many times I'd have to come here before I was able to try every possible thing in every possible way. So if you wanted like every combination possible, and that is what we have here at apparently a cafeteria. So if we have a main dish, a side dish, a vegetable, a salad dressing, and a dessert and a drink, how many possible choices and ways could we put together a meal? Well, if you have a main dish and all this stuff, you would end up multiplying all the way down to get that. So it'd be 3 times 4 times 2 times 2 times 3 times 2 times 3, which is a whole lot of possibilities, and that is okay. 3 times 4 times 2 times 2 times 3 times 2 times 3. If you multiply all of those together, you get a really big number. You get 864 total possibilities for this given scenario, which is how some restaurants can claim that they have like 30 million different flavor combinations because they have like 30 different flavors and you can mix 5 of them together. Okay? So, moving right along. This time we're going shopping on a website showing that there can be outdoor patios. There are 4 types of stone, 3 types of edging, 5 dining sets, and 6 grills. He wants to buy 1 from each. How many different scenarios could he have? And that is quite a bit as well, because again, we are multiplying 4 times 3 times 5 times 6. I promise these will not all be the same. 4 times 3 times 5 times 6 ends up being 360 different patios for this guy, who's it, Kamar. The next one I want to do is involving a spinner. So the spinners are very popular, and with you spinning, every single time it's going to be the same amount of possibilities for each and every spin. So if the spinner is used on a board game, if the spinner is spun 4 times, how many different possible outcomes could be? Well, you could have a 1 for the first number, or you could have a 5, or you could have all these different possibilities for the first number. In fact, in first spin, you have 6 different possibilities. Well, what about on the next spin? On the next spin, you still have 6 different choices available because the spinner didn't change. And the next one, you still have 6 different choices. And the next one after that, you still have 6 different possibilities for you getting those numbers. And if you multiply all of these together, you would end up with 6 to the 4th power, which is 1,296 different possibilities for this one simple situation. Okay? So, let's see what else we can come up with. We have, for our next one, we have suits and ties and things like that. So Maurice packs suits, shirts, and ties that can be mixed and matched. He is using a list to draw the tree diagram to represent the sample space suits combination using 1 category from each one. So he is only going to pick 1 suit, 1 shirt, and 1 tie, but the tie is optional. That's the kicker here. The tie is optional. He's got to wear a suit. He's got to wear a shirt. But the tie is optional. So the first thing we're going to do, he only has 1 tie available, so that's nice, is we're going to do 3, because we have 3 suits, times 2 shirts, and then he is either going to wear a tie or not. If he wears a tie, he is going to wear a striped tie. If he is not going to wear a tie, he's just not going to wear that striped tie. So that would also be 2 different possibilities. Therefore, we would have 3 times 2 times 2. 3 times 2 is 6 times 2 makes 12 different possibilities. Okay? Moving right along, let's see what else we can get. I'm trying to come up with some unique ones. Let's see what we got on the next page. A combination lock has 4 different number combinations. Each number is a number from 0 to 9. This very popular type of question, this like password question. How many combinations are possible if there is no restriction on the number of times that Tallulah can use each number? Well, from 0 to 9 is actually 10 different numbers. And if there are 10 different numbers in the beginning for that first digit in a 4-digit combination, the next digit could also be 10 different numbers, and the next digit could also be 10 numbers, and 10 numbers for all 4. And if we multiply all of these together, you end up with 10,000 different possibilities. Quite a bit. But in a lot of these questions, they say that sometimes you can only use a number once. You can't repeat a digit. That way you don't come up with a combination that's like 1, 1, 1, 1, 1, which is very easy to crack. So if the numbers can only be used one time, well, that first number, you could have all 10 digits available from 0 to 9. But then if you've used one of them, the next combination digit can only be 9 possibilities. And the one after that can only be 8 possibilities. And the one after that can be 7 possibilities. And if we do 10 times 9 times 8 times 7, you would end up with a number which is 5,040 different possibilities. That is quite a bit. All right, perhaps only one more. Hugo and Manette are playing a board game in which the player rolls 2 fair dice per turn. In one turn, how many outcomes result in a sum of 8? Apologize for it being slightly off the screen. So a sum of 8. So we have to think, how many ways can we get it to equal a sum of 8 if we have 2 dice being rolled here? Well, if we roll a dice, that we could roll a 1 and a 1, a 1 and a 2, 1 and a 3, 1 and a 4, a 1 and a 5, and so on and so forth. But none of those actually end up giving you a sum of 8. But you could also roll a 2 and a 1, a 2 and a 2, a 2 and a 3, 2 and a 4, 2 and a 5, and a 2 and a 6, so on and so forth, right? And a 3 and a 1, and a 3 and a 2, and a 3 and a 3, and a 3 and a 4, and a 3 and a 5, and a 3 and a 6. So out of these, how many of them are going to actually equal 8? Well, a 2 and a 6 would, and a 3 and a 5 would, but you also have to realize that if you were to go into the 4 category, a 4 and a 4 would also win. But you have to think of the second dice. A 5 followed by a 3 is different than a 3 followed by a 5, and a 6 followed by a 2 would be different than a 2 followed by a 6, because you have to think of it like if you rolled one dice and then the next dice. The first dice could be a 2 and the second dice could be a 6, but the first dice could be a 6 and the second dice could be a 2. So all in all, you end up with 1, 2, 3, 4, 5 different possibilities. Now, how many of them would result in an odd sum? Well, I think that would be a little bit easier to figure out if you knew the total possibilities. So the total possibilities, if you have 2 dice, if you kind of look at this real quick, we got 1 and a 1, a 1 and a 2, and a 1 and a 3, and a 1 and a 4, and a 1 and a 5, and a 1 and a 6. That is 6 things. And then a 2 and a 1 and a 2 and a 3 and a 2 and a 4 and a 2 and a, all that is 6 more things, and another 6 more things. We would end up with 36 total possibilities. How many of those are going to end up being odd, you think? Probably half, right? And it would be correct. 18 out of the 36 would be odd. We are going to continue doing these. We're going to have permutations and combinations coming up very soon, followed by probability. Probability is essentially taking the total outcomes and dealing with what is the likelihood of having a sum of 8. And that would end up being 5 out of 36. It's very simple, but it's still slightly different. I will see y'all in the next one. Until next time, stay positive, my friends. Bye.